Today's lesson 1-5 involves solving equations with variables on both sides. So let's look at example 1. So remember, our goal is always to isolate the variable term. Well, the problem with this type of equation is you've got a variable on the left and a variable on the right. I always suggest that you move whichever variable is smaller. So we've got to either move the 7x to the right or the 4x to the left in order to get them together on the same side. So out of 7x and 4x is smaller, I suggest you move the 4x. In order to move the 4x, you have to add its opposite. So the opposite of 4x would be a minus 4x. So I'm going to subtract 4x from both sides. The 4x's on the right cancel. 7x minus 4x is 3x equals 15. And now you have a simple one-step equation. To solve for x, divide by 3. So x equals 5. Example 2. You try example 2 on your own, pause the video, do the problem, and then turn the video back on. I will do it quietly. So your value is x equals 3. The next section regards simplifying each side before solving equations. So it could be collecting like terms, it could be using the distributive property, but you've got to clean up the left side and clean up the right side as much as possible before you start moving terms back and forth across this brick wall. So in example 1, using the distributive property, I can multiply the 2 through into the parentheses. So 2 times y is 2y. 2 times 6 is a positive 12. I didn't do anything with the right side, so I'm just going to bring down the 3y. Now I have a y term on the left and a y term on the right. Out of those two terms, the 2y is the smaller. So I'm going to move the 2y to the right. The opposite of a 2y is a minus 2y. So I'm going to subtract 2y from both sides. And we get a 12 on the left and a y on the right. So look at example 2, pause the video and do that on your own and then restart the video. I'll do it quietly. So in this one, I chose to move the minus 6k to the left because remember, negatives are always smaller than positives. You could have moved the 2k over to the right by subtracting 2k. You just would have gotten a negative 8k over here, and you would have had to deal with the negatives. So long as you still got k equals 1, you have a correct solution. So for example 3, we now have a combination of collecting like terms on the left and a distributive property on the right. So let's collect like terms here and here. Because they're both b terms, I'm going to add their coefficients. I don't do anything with the 3, so I'm just going to rewrite it. Don't forget your brick wall. And then the negative 5 and the positive 2b different sign subtract, so we get minus 3b equals. And then we're not going to do anything with this negative 2, so we're going to bring it straight down. However, we're going to distribute a negative 2, not just a 2, but a negative 2 to everything in the parentheses, because this negative belongs to the 2. So negative 2 times 1 is negative 2. Negative 2 times a negative b is a positive 2b. A negative 2 and a negative 2 do not cancel each other out. So remember, if you keep change, you have a negative 2 plus a negative 2, which equals a negative 4 plus the 2b. So that's what your right kind of cleans up and looks like after it's all nice and pretty. And then the left I can't do anything with, so we're just going to bring down the 3 minus 3b. So we have a variable term on both sides. The negative 3b is smaller than the 2b, so we are going to add a 3b to both sides. And we end up with a 3 on the left equals negative 4. A 2b and a 3b is a positive 5b. Now we want to get the 5b by itself, so we've got to get rid of the minus 4. So we're going to add 4 and add 4. We get a 7 on the left equals 5b. And now to solve for b, to undo 5b, we're going to divide by 5, divide by 5. And remember, if there isn't a decimal in the original problem, you don't have a decimal as an answer. So there's your solution. Let's look at, I think that's the last one on that slide, so we'll look at the next one. So for this one, we're going to identify whether there's no solution or many solutions, or oftentimes you'll hear me call it infinitely. Many solutions, or all real numbers. And all that means is that any number you can think of for x would be the solution. With no solution, no value of x would make the equation true. Normally we have just one solution. As you've seen with all the problems we've been working, we always have one solution for these problems. And the reason why we have one solution is, as you look at this polynomial, it has a degree of 1. No term has a degree higher than 1. And so it's a linear polynomial, and the degree of that polynomial usually tells us how many solutions. Well, normally we'd have one solution, but it is possible that you can write an equation that doesn't exist. It's not actually equal. And so you could have a no solution. Or we can write an equation that's called an identity, which is your infinitely many solutions. So let's look at those two examples. So let's draw your brick wall. On the left side, we can combine our like terms of x and negative 6x. That gives us a negative 5x. We're not doing anything with a 4, so I'm going to bring it straight down. Equals. On the right side, I can combine the 6 and the negative 2 as constants. So 6 minus 2 is 4, and then I'm not doing anything with a minus 5x. As you can see visually, the left side is identical to the right side. However, I want you to keep going until your variables drop out. Don't concentrate on the constants, concentrate on your variables. So you have a negative 5x on both sides. Neither one of them are bigger than the other, they're equal value. So if we were to try to move the negative 5x to the right or the negative 5x to the left, either way you'd be adding a 5x to both sides, because that's the opposite of a negative 5x. And look what happens. Both sides, your variables drop out. You're not left with any variables. Anytime your variables drop out on both sides of the equations, it should be a clue that you either have infinitely many solutions or no solutions. To find out, look at what's left over. You have a 4 on the left and a 4 on the right. Is this a true statement or a false statement? If it is a true statement, so in this case, 4 equals 4 is a true statement, then your answer is infinitely many. solutions, or you can say the solution is all real numbers. Any number you can think of for x, 0, positive, negative, fraction, decimal, it will work in the equation. Go ahead and try a couple of values and do a check on it. I'm not going to take the time to do it here. All right, look at example 2. So here's our brick wall. On the left, we can collect the negative 8x and the 9x. Together, that gives me positive 1x. I can't do anything with the 6, so I'm going to bring that down. On the right side, I can't do anything over here. Can't collect like terms, there's no distributive property. However, I have an x on both sides of the equation. They're identical in value, and so, you know, it's hard to choose which one do I move. It doesn't matter. You're going to either move the x to the right or the x to the left. The opposite of x would be a negative x. So as you try to subtract x from both sides, your x's completely drop out. You have to look at what's on the left and compare it to what's on the right. Because 6 does not equal 17, negative 17, this is a false statement, and therefore your solution is no solution. This last problem is a word problem, and it says the long distance rates of 2 phone companies are shown in the table. How long is a call that costs the same amount no matter which company is used, and what is the cost of the call? So let's go ahead and there's several questions there, but let's go ahead and answer the first question. Well, first of all, we have to figure out what is our variable. So step 1, let x equal your number of minutes. So then step 2, we are going to define, or we defined our variable in step 1, but step 2, we're going to come up with our equation to solve. So if company A, if they charge 36 cents plus 3 cents per minute, that means that 36 cents is a constant charge, and then they're going to charge you 3 cents per minute. We don't know how many minutes we're going to talk, that's X minutes. So the expression for company A would be 36 plus 3x. This is your 36 cents plus 3 cents per every minute. Whereas company B is just 6 cents per minute. There is no constant cost. So for company B, this is 6x. So to determine how long is a call that costs the same no matter which company, you're going to set the costs of each of these companies equal to each other, because if this cost equals this cost, we'll find the number of minutes that create that situation. So 36 plus 3x equals 6x. So we have a variable on both sides, and we want to get rid of the smaller one. So 3x is smaller than 6x, so I choose to move the 3x by subtracting 3x from both sides. That gives me a 36 on the left equals a 3x on the right. So to solve for x, we're going to divide by 3, and we get 12 is equal to x. So that means that if we talk for 12 minutes, the cost for company A is identical to the cost for company B. And the last part of the problem is, what is the cost of the call? Well, it doesn't matter whether you plug it into 36 plus 3x or 6x. They should both give you the same answer. So let's plug it into both, and I'll just prove to you that it doesn't matter which one. So we're going to plug in the 12 minutes into each of these. And so for company A, so this one's company A, and this one's company B. So for company A, we end up with 36 plus 36, total cost of 72 cents. And for company B, 6 times 12 is 72 cents. So to answer their question, therefore, if a call is 12 minutes long, the cost for both company A and B will be 72 cents. And this is your homework assignment. Have a good afternoon.